Continuation from the diagram. Now we have already proved that the resultant of two vectors acting at an angle theta to each other is square root of p square plus p square q square plus 2pq cos theta. Now how can we find alpha? Remember, alpha is the angle which the resultant make with the horizontal. Now to find the angle which the resultant make with the horizontal alpha, so we are going to use SOHCAHTOA tan alpha. So still trace our triangle like this. So that means tan alpha is equals to opposites, that is p sine theta divided by adjacent q plus p cos theta. So that means alpha is equals to arctan p sine theta divided by q plus p cos theta. So that is angle which the resultant makes with the horizontal. Now there are some deduction that we have to prove here. So I'll start with this general formula now so we can have different cases. So now let's have different cases here. We have r, we have shown that r is equals to square root of p square plus q square plus 2pq cos theta. So now we have different cases here. So now case 1. Case 1. If two vectors are parallel, and act in the same direction, then the angle between them is 0. Why is angle between them 0? Now note this on vectors. Note, vectors are movable, meaning I can move vectors from one point to another. So if I have vector here and another vectors here, I can move this vector like the way you see it now. See it here? I can move this vector the way you see it moving this way. I can move it, so I can move it anywhere. Vectors are movable. If I like, I can move it here to form another vector. If I like, I can move this vector here to form another vector. So vectors are movable. I can move it. If I like, I can move this. So move vectors anyhow is allowed. So vectors are movable. Note. And again, vectors makes angle head tail to tail. If this is vector, this is head, while this is tail. Now for two vectors, the angle between two vectors must be tail to tail. Now consider this diagram here. Now if this is a vector, this is a vector, and this is a vector, if the angle here is 120 degree and the angle here is 60 degree. Now if you compare this, if you look at this diagram now, what is the angle, what is the valid angle in this diagram? Now if you trace this vector here and this vector here, you will see the angle formed is head to tail. So vector cannot form angle head to tail. So if you trace this other one, this is tail, this is another tail. So vectors are always forming angle tail to tail. So if you have two vectors like this, you can't form angle here, is wrong. So vectors form angle tail to tail. So now with this concept, we can now go back to this place. So if two vectors are parallel and act in the same direction, now let's move these two vectors together. Now they are parallel and act in the same direction. So now let me move it. No matter how I move it, so now I'm moving this one first. Okay, see this, I'm moving this. Now I'm moving the second one also. I'm moving the second one. Now I move this one here. If I move it to form a straight line, what do you notice? It means head of one is at the tail of the other. I cannot form angle here. I can't form angle here because I can only form angle tail to tail. Okay, let's try another movement. Now I'm moving these vectors again. So I move this one here. So no matter how I move this vector, it will always be head to tail, and I can never form angle no matter how I move it. Now remember, if you are moving, you can never change direction, meaning you can't move and change direction. So look at this now. I can rotate it like this. So I can't rotate this vector. I can't rotate it this way. It's wrong. So this I must leave it the way it is, and I cannot change anything. So that means without rotating or anyhow, no matter how you move it, it cannot form angle because it will always be tail to head, so it can't form. So that means in this case, if two vectors are parallel and act in the same direction as we see it here, then the angle between them is 0. So the angle between them is 0. As you can see, no matter how we move it, it can't form what we want. No matter how we move this, it will always be this. So an angle cannot be formed there. So far angle cannot be formed there, so the angle between them is 0. So take note now. So if two vectors are parallel and act in the same direction, then theta, the angle between them is 0. Now if the angle between them is 0, what is now their resultant? Now let's see their resultant. So go back to this general formula. So now theta is 0, so put theta to be 0 here. So that means r is equals to square root of p square plus q square plus 2pq cos 0. Now if you press calculator, cos 0 is 1. So that means r is equals to square root of p square plus q square plus 2pq, because cos 0 is 1. Now this is r equals square root of p square plus 2pq plus q square. Now this is quadratic equation, so let's try and factorize. So r is equals to p square plus pq plus pq plus q square. So bracket it 2. So what is common in the first bracket? I'm trying to factorize here. So this will be p, then p plus q, then plus q, p plus q. So now r is equals to square root of p plus q and p plus q. That is, this p plus q, take one and take the outside one. So this is the same thing as r is equals to square root of p plus q square. So now these roots will cancel out these 2. So r is equals to p plus q. That means if two vectors are parallel and act in the same direction, then first theta will be 0 and resultant will be p plus q. And take note, in this case 1, there is a maximum resultant. So that means if question asks What is the maximum, or when can a vector have a maximum resultant? It is when the angle between them is 0 and they are acting parallel in the same direction. So if two vectors are acting parallel in the same direction, the angle between them will be 0, then they will have maximum resultant, and that resultant is p plus q. So if this is vector p and this is vector q, so their resultant is just to say this vector plus this vector, on a condition that they are parallel and act in the same direction. Okay, so now let's say case 2. What if they are parallel and act in the opposite direction? So let's see case 2. So case 2. So before case 2, we need to know the angle which the resultants make in that case. As in this case of if they are parallel and act in the same direction. So what is alpha here? The angle which the resultants make with the horizontal. So p sine theta over q plus p as proved before. So that means if theta is 0, arctan p sine 0 arc p sine 0 over q plus p cos 0. So now alpha is arctan sine 0 is 0, so everything here is 0. Alpha is 0. So it means angle which the resultant makes with the horizontal here in this case is also 0. So take note, in this case resultant is maximum, and if resultant is maximum it means the two vectors are parallel and act in the same direction and the angle between them is 0, and that resultant is p plus q. So let me continue in the other video.